easy big starter question, right? Has anyone been thinking about this? The council are spraying weed killer on your local park tomorrow. They say it will not kill the dandelions, which are obviously used by bees and other pollinators, very important plant. You're worried it will kill the dandelions. So you're going to need to know how many dandelions are in the park before the spraying and then after the spraying to prove if the dandelions have been killed. But the park is massive. There are thousands of dandelions. What do you do? Hello, Science Alliance. Well, someone on Facebook yesterday was like, well, I'd just take a couple of dandelions, test them with the weed killer the council were using, and then see what happened. Yeah, all right, fine. But sometimes scientists need to count very, very large amounts of animals, okay? Or plants, indeed. You might need to count things to figure out if they're endangered or not, to figure out if numbers have dropped. Or you might have done something that you're hoping will protect the animals or plants and make the numbers rise again, but obviously you need to test whether what you've done is working. So, what you would do is, well done if you got it. You would, well, no, I'll tell you what, I'll give you a clue first of all. If you have been to my Facebook group and you have downloaded the worksheet, you have already got a piece of paper in front of you, hopefully, that looks like this, you lucky devils. If you haven't got a piece of paper that looks like this, 8 squares across and 4 squares down, you are going to have to draw one now. Gasp. Don't worry, it'll be okay. All you have to do, you can't fold it. Usually we fold paper on Theatre of Science, don't we, to get the lines straight, but we can't do that. We're going to have to just draw lines, but basically just half the paper, draw a line right in the middle of the paper, and then draw a line, so you've sort of split the paper into 2 sides, right? And then draw a line through that, and then draw a line through that, and just keep splitting your paper into 2. You'll see what I mean. So I've split my paper in half with this line, and now I've got 2 halves of paper, so I'm going to split that bit of paper in half, okay? And that bit of paper in half, and then do that twice more. So this is quite tedious, obviously, if you already have this worksheet in front of you. Can you guess why we're doing this? I think hopefully you can. Maybe some of you were doing it on Facebook yesterday. What you do, if there's, say, millions and millions of dandelions, and 1, 2, 3, 4, 5, 6, 7, this is very badly done, isn't it? You could just count a small proportion of the dandelions in the field. Say, count the dandelions on like 10% of the field. And then if you count the number of dandelions on 10% of the field, and you times that number by 10, you would hope, wouldn't you, that you would have quite a good estimate of the amount of dandelions in the field overall. All right, this is shoddy. But not to worry, hopefully you've got something that looks a bit like that. So we're going to say for ease that our field is just a rectangle, okay? And we've now split our rectangle into 8 different segments. Here we go. What we need now, you can be carrying on doing that while I'm chatting. We need something called a quadrat. Please note the spelling, not a quadrant, a quadrat. I think I might have accidentally spell checked it and the computer wrote quadrant on your sheet. It's a quadrat. What is a quadrat? Well, it's basically just a square. It's a wooden or a metal kind of frame, almost like a picture frame, which is often 1 metre by 1 metre, 1 metre square. But if you were putting your quadrat on a tree, it might be very, very small. And all you do is, you put your quadrant down on your field, say. You would count how many dandelions are in your quadrat, and then you would do that however many times. You know, you could do it 10 times, and then you would know that you'd measured 10 metres square of that field. And then you just times it by however much you need to times it by to work out in the whole field how many dandelions are growing, okay? So here's a very quick quiz for you. It's not a quiz. You can count the dandelions in, say, 10% of the park, times the answer by 10, all right? So you're most familiar with the playground bit of the park. So could you go over to the playground where the slide is and stuff and put all your quadrats down there? Could you do that? Would that be a good thing to do? And then say that you measured like 10%. Could you just times the amount of dandelions you find in those quadrats by 10 to get the amount of dandelions on the whole field? I'll give you a clue. No, of course you couldn't do that. No, that would not be a fair test, would it? Because, why? Well, the area near the playground might be particularly trampled or weed on if it's a playground that my daughter uses. It would not give you an accurate picture of how many dandelions there were in the park, would it? And even if you put that quadrat where the grass was all lush and where there were loads of dandelions, that still wouldn't be a fair test because there's loads of dandelions there. What you've got to do, and it's much, much harder than it seems, is you've got to put your quadrats, let's say you're putting it down 10 times, you've got to choose totally random bits of field. This is much hard. It's very, very difficult in science to be truly random, because you might think that you've dropped it down randomly, but even if you've got a great science brain, you're going to be like, oh, there were quite a lot of dandelions in that bit. To be fair, I'd better choose somewhere where there aren't many dandelions. No, this is not fairness, okay? So what we're going to do is, I have got a random name generator here, and it's got all different squares in it. And what we're going to do is split our field into different named segments, and then I will sort of give you a random segment, and you can look at that one. So right, here's what you need to do. Trying to do talking and doing things at the same time never works for me. What I need you to do is, if you finish drawing those segments, you just need to label them 1, 2, 3, 4, 5, 6, 7, 8 across the top, and A, B, C, D down the side. I will do that too in real time, so you should be able to do it at the same time. Okay, just write the numbers 1 to 8 across the top. 5, 6, 7. Oh my goodness, I just wrote. Oh, I'm so bad at multitasking. I just wrote 5, 8, 9. 5, 6, 7, 8, and A to D down the side, right? Phew, we got there. And then stick it in the baking tray, please. So you should have something that looks a bit like this now. Boop, there. The baking tray is just to stop the beans spilling, because what we need to do now is, first of all, I just need to check that you're okay with how to read grid coordinates. So if I asked you what's like the name of this segment, would you be okay that that is B4, all right? You find B, you find 4, and that segment is B4. And this one, what's this segment going to be called? A lot of you will know how to do this already. If you don't, hopefully you've picked it up. This one is 6D, or D6, okay? So what I need you to do, if you've got a very, very small amount of dried beans or grains of rice or something like that, only use a really small amount, because you need to count them at the end of this. And I used what I thought was just a small tablespoon, and it was 500. It took me ages. It was a total nightmare planning this lesson. So if you've got just a very small, like less than a teaspoon of grains, sprinkle them onto your bit of paper. And we'll say that this is dandelions in our field. Excuse me. So any that go onto the actual baking sheet, you just need to collect them up and put them on. Just the nearest segment there. It's tricky, this, because they've got to be random, and random obviously doesn't mean equally spread. Equally spread wouldn't be random at all. But I am going to give them a little shift around. There we go. Right, I'm going to leave it there. Excuse me. Must be incredibly unpleasant to listen to. If you have downloaded the sheet from my Facebook page, then I've left the title blank. You can pretend that you're counting anything you like, but this quadrat system is only used for either plants or animals that move incredibly slowly. So if you wanted to count the amounts of like wood lice or slugs in a field, you'd be okay to put that quadrat down. You can't, obviously, if you're counting like red deer, this quadrat method is not going to work. We will look at that later. So how many dandelions are in our field? What I'm going to do is, if you're ready, I'm going to show you this Wheel of Fortune, which will randomly generate a segment for us, and then we'll go to that segment and count how many dandelions or whatever you're counting there are. Only count grains of rice or whatever you're using that are completely within the square. If there's one like that's straddling across the line, you can't use that one. Okay, volume up, because I love this thing. Here we go. Are you ready? It's such a brilliant website for teachers. It's provided for free. It's amazing. Here we go. Which segment are we going to investigate? It's A7, everybody. Okay, A7. So find A. Find the 7. Oh, what a start for me. So there are no dandelions growing in this bit of my field. So I'm just going to write a 0. But if you have got some, obviously you would write down however many there are. So in quadrat 1, I'm going to write a big fat 0. There we go. Are you ready? Have you done that? So don't forget, if it's straddling the line, then only choose ones that are completely within the line. Now, do I remove it or not? I'm struggling here a bit, actually. Yesterday, I suddenly thought, I don't know whether I should keep this in and then we could count the same one twice, because that is truly random, or whether we should not count the same one twice. I think I've been keeping it in, but actually I think I'm going to remove it. The odds of picking the same one twice are quite small anyway. B8. B8 is our second segment. B8. Find your B. Find your 8. Gasp. So I've got 2 growing. I'm going to stop saying the numbers because I imagine it's really annoying if you're trying to count. So find B8 and write down how many are in that segment or that quadrat. Let's do the next one. It's D3, folks. D3 is the segment we are looking for. So D, 1, 2, 3. And I've got one that is on the line, so I'm only going to count the other one. So D3, however many you've got in D3, write that down. Okay, next one. I feel like I'm making this far more exciting than it has to be. A5. So go to A5. Okay. Like I said, I'm going to try and stop saying the numbers because it will get really annoying for you. A5. What's in A5? Write it down. And the next one. B7. All right, so go to B7 and count how many. You can see how the numbers do, like a different person doing it might get a slightly different result. Okay, so what's that? 3 more to go. That noise is getting really annoying. C3. So find C3. How many are in C3? Ooh. Okay. C3. 2 more to go. Yeah, I'll turn the sound off now, sorry. Or maybe I'll just have it quiet. D8, so find D8. D8, that's an easy one for me. Write down how many, or dandelions, whatever you found in D8. And finally, the last one. It's B1. B1 is our last one. There we go. That's easy. Right. And then what you have to do when you've finished that, obviously if you miss one, just try and choose a random segment. You need to add all those numbers up together and tell me what you got, right? So I'm don't be a hero. If you need to use a calculator, feel free. I am trained to teach physics at A level. I'm going to try and handle this myself. Okay. Right. Oh, that's interesting. Very interesting. So I get 13. Which is interesting for me because I know for a fact that there are 100 grains in my field because I counted them before. You don't need to count them yet. But what we're going to do is, how are you going to use that number Hello, haven't seen you for a while. So you've counted how many grains altogether, hopefully, are in 8 random segments of your field. How are you going to use that number to work out how many grains are in the field altogether? What are you going to do? By the way, I made it like a bit more silly than it had to be, but that is what scientists would do. They would have just a piece of software that does randomly generate a grid coordinate, and then that's how they would pick it. Or if they were using a tiny tree, they would split the tree into different little segments and randomly choose those ones. Well, did you work it out? We've got 32 segments in our tray, and we've counted the grains in 8 of them. So that's a quarter, right? So if we know the amount of grains on average in a quarter, if we times that number by 4, then we get an estimate for the total number of grains on the tray. So I was surprised, really, because the number that I counted altogether was only 13. So I do 13 times 4, and what's that? That's only 52, isn't it? Which isn't very good at all. It's not a very good estimate. But that is quite interesting, because I know that there's 100. You can count yours later. So, but that is quite interesting for me, because when I've done this lesson 3 times now, and the first time I got 100 exactly, and I was really impressed with my amazing estimate. And the last lesson I did, I got 130, and I was like, what? That's too much. But now I've got 52. So traditionally, biology, it turns out, in real life, can be really quite tedious, because what you'd have to do is do that experiment, that activity, again and again and again and again, end up with loads of estimates, and then you would find the average of that estimate, and hopefully the more times you do it, the more accurate your estimate will be. So I'll tell you what, I'll just do it now. I got, to find the average, you just add them all together and divide them by how many of them are, yeah? So my first day, I got 100. My second day, I got 130. And my third time I did the lesson, I only got, what was that, 50, can't remember, say 54, 52. So if I times that by 3, and then if I add them all together and then divide it by 3, I get an estimate of 94, which is not bad, actually. So depending on how much time you've got today and how interesting you're finding this, you could try that again and again and see how you go. Right. So like I say, that's all very well if the thing you're trying to count isn't moving. But if the thing you're trying to count is moving, you've got to do something different. So when you've finished adding them all up, get all your grains and pour them into a bowl, please. And we're going to do something else. We're going to imagine that these grains are now an animal that can move around. It's up to you what animal you would like to choose. In yesterday's lesson, someone decided that they would like them to be tigers. I think it's a bit optimistic that there are 100 tigers in our habitat here. But okay, I have in my bowl 100 tigers. You can decide what your live animal is that can move around, and what you've got to do, this is what scientists would do. If you were in an environment where there were lots of tigers, well, let's say wolves is a better example. Whatever animal it is that moves around a lot, you've got to capture some and tag them. So take out 20 grains from your bowl, and what you need to do is you need to tag them in some way. What we're going to do is just colour them in. So take 20 grains out of your bowl and colour them in. This is where my multitasking completely fails, and I literally just have to count them in front of you. I'm so sorry. So I'll do it in 2s. You be doing it too, please. Get 20 grains. See, I just talked and now I've lost track again. Phew, okay, so I've got my 20 grains there. And then I need to tag them by colouring them in. I'm going to tag them by putting them all in the palm of my hand and stabbing at them gently with a pen while I chat to you. But if you don't like getting pen all over your hands, you could keep them on the baking tray or whatever, or piece of paper. But yeah, we'll tag our living creatures, whatever they are, by colouring them in. There are loads of different ways that actual scientists in the actual world can tag living things. Speaking of tigers, because people are quite keen on tigers, how you count a tiger is, luckily, the patterns on a tiger are basically like a fingerprint. They're very individual. So to trap a tiger, you don't have to touch it. You just set up a camera trap, which is a camera that is set to go off when a big animal like a tiger moves past it. And then you just look at all the different photos over a certain amount of time, and you would count, you'd look at the patterns on the tiger and count how many different tigers there were based on the patterns. So that's a nicer way to do it. We were talking the other day about if you want to tag a great white shark, if you stroke it on its nose, don't do this, but if you stroke this on its nose, it becomes like immobile, and you can put a tag on it that way. It's really important that scientists tag an animal in such a way that it doesn't affect their behaviour. Because cruelty, obviously, like you can't put a big tag on a bird that makes it not be able to fly. And also because it wouldn't be a fair test. Like if you want to, say, tag, I don't know, cuckoos to see how far they fly, if the tag that you've put on them means that they can't fly very far, you're not going to get good results. So I send all my supporters the magazine, Plug. And I think in one of the most recent ones, there was a story about how they've invented a tiny little tag that you can put on a moth. So for the first time, scientists were able to study like where moths fly, because finally the technology meant that we had a tag that you could put on a moth. You've got to think about the weight of it. You've also got to think about the colour. Like if you put a big garish coloured tag on something and it's going to make it less likely to reproduce, like the members of the opposite sex are not going to want to mate with it because of its big tag. That's also something to consider. So it's like a science all of its own, that we're always evolving how we tag animals. Okay. I think I've stabbed at my tigers in the palm of my hand enough. I'm now going to release them back into the wild. So if you've coloured in your grains, release them back into the wild. This is what would be done. Like I say, not tigers. Wolves you might capture and then put a collar on a wolf. So let's maybe say that these are 20 wolves that have all got collars on. And we're going to release them back into their population so they're free to mix with the wolves that haven't got collars on. Now what we need to do is, and this is what scientists would do, maybe a day later, a few hours later, or a couple of years later, depending on the study, you would take a sample of animals from the habitat and count how many you'd got all together and how many were tagged. So that's what we need to do. I'll just show you the instructions written down, so that might be helpful. This is the trapping method for organisms that can move. Take 20 grains, mark them all over with a felt pen, and that's what we call our first sample. And then you put all the grains, marked and unmarked, into a bowl. You've got to take a pinch of grains, count how many there are, and how many are marked, and record it in a table. So again, if you've got the worksheet, this is a bit easy for you, because you've got this table. If you haven't got this table, you might want to be very quickly sketching it out now. So I've just written pinch 1 to 10, because we're going to take 10 pinches altogether. For each pinch, we're going to write down how many grains we got. It might just be like 2 or 3 or 7. And also count how many of those are coloured in for each pinch. Whew. And we've got to do that 10 times. So I'm going to do it in silence. I don't usually do this in my lessons, where I just kind of say over to you and I'll silent for a long time. But I don't want to say it out loud, because a lot of you will be doing it alongside me and it might get quite tedious. But yeah, that's what I'm going to do right now. So I'll do the first one with you and then you can do it in your own time. Take a pinch without looking, because otherwise you might bias the results. Count how many wolves are in your pinch. 1, 2, 3, 4, 5. So I've got 6 altogether, and one of them has been marked with my pen. So I'd say, okay, pinch 1, the total number of grains I got was 6. And the marked grains, there was just 1, okay? So 6 grains altogether in pinch 1, and one of the grains had a pen on it, right? And then you've got to put all those grains back in the bowl. You can't keep them out of the bowl, or you won't get a good result. Put them back in the population, give it a swirl, and just do that again. And do that 10 times. So yeah, I must admit, it's a bit of an experiment, this. Hoping that you don't all just get really bored and turn off. But I'm going to now in silence fill in this grid, and you do the same thing. And if you are watching me, then by all means do. But yeah, I won't be speaking too much. So here's my second pinch. So you're doing this with yours as well, yeah? Don't forget to put the pinch back. And I looked and I deliberately went for ones that were marked, so I'm going to do that again. Sorry, this chair's making this bit sound a bit like a horror film. Sat on a very squeaky chair. Right, I've got 3 more pinches to go. If you're working much faster than me and you finish, you could be thinking, how on earth is this going to get us to a place where we can estimate how many tigers are in the population altogether? How? Because don't forget, obviously, we're going to be able to count our grains quite easily, but you might have absolutely no idea how many tigers are in your forest or how many wolves there are where you are. Okay, I'm on my last one. Ooh. Okay, I have finished. Whew. So, what we need to do is you need to come up now with a couple of numbers. You need to count the total number of grains that you pinched. And this is what we call S. That's the size of your second sample. So the total number of grains that you pinched, right? So for me, that's all the ones in my middle row here. And yeah, I'm sorry, I'm not going to be here about it. I'm just going to use calculator, and then I can test again and again whether I've got the right answer, okay? So I'm going to do it in silence so that you can do your numbers alongside me if you are. Right, I've got an answer. I'm going to just put it in again to check I was right. Good. Right. So my value for S is going up on the board now. Total number of grains that you pinched. And the next number that you need is the total number of grains that were marked that you pinched. So the bottom row, the total number of marked grains. So that's going to be a much smaller number. Okay, so I've got a number. I'm just going to count it again to make sure. Right, there we go. And that's the number that you call R. That's the number of marked grains. And then the other number that you need is called M, and that is the number that you first marked. So if you've done it the same as me, that will be 20. And then it has to do with ratios, this. I will post in my Facebook group after this lesson, actually, because I've got some time before my next lesson. I'll post a link to the website which explains really beautifully where you get this equation from. Or you could just think of it as dark magic, depending on what level you're at. But if you use this equation, N is the number of grains in your bowl altogether, like the number of wolves, okay, the number of tigers in the forest. That's the number that we're trying to find. If you do M, which is 20 for us, times S, the total number of grains that you pinched, and all that divided by R, the number of grains that were marked that you pinched, you should get an estimate of your population. This is a moment of truth. I'm going to try it right now. This is the one where I've had very different results. M times S. And the whole thing divided by R is, oh, hey, pretty good. Whew. So I know for a fact that there are 100 grains in my bowl, and I got 111. Very good. You will have a different number probably, and you probably don't know how many grains are in your bowl yet. You can count them at the end of the lesson and see what number you get. Yeah, so that equation, if you just want to quickly scribble it down if you're a bit behind, is M times S divided by R. But it's on a sheet on my Facebook group as well. Yeah, and again, I'm saying like, oh yes, I got a good result. Obviously, if I was actually a scientist in the field, I would have no idea whether that answer was accurate or not. What I would have to do is just do that again and again and again and again. Like the first lesson, I was really embarrassed because I only got 50. I was like, oh no, I've done something wrong. And then the second lesson, I got like well over 100. And then this lesson, I've got 100. So again, if I did that loads of times, added them all together and found the average, then hopefully you would have quite a good estimate. Just amazing. So there are, just before we move on, there's another thing that you can do, which is not completely random sampling. So we've looked at how if you get a quadrat, you need to put it in a completely random place so that you don't bias it. There is a way of doing it that if you want to spot a pattern, say that, wow, that's really bad. Say this is the ocean, and you want to do a study to see if the amount of crabs on the beach changes the further away you get from an ocean. So in that case, what you would do is you would want to have a line running from the ocean to, I don't know, like as far back as you want it to go. And that is called a transect. And it's literally just a rope or a bit of tape on the ground. And in that case, you would put your quadrat at regular intervals along the line. Like every 2 meters, every meter, depending on the study. And you'd count how many crabs in each one, and you'd see if there was a pattern, like more crabs near the water, fewer crabs away from the water, on average. I saw a brilliant study where there's a certain kind of heather that grows on the moors that is quite damaging. Like it grows really fast, it chokes all the other plants, it's not good. And one of the ways that they deal with this, what I'm going to call evil heather, because I can't remember the name of it, is they would just burn it. But obviously that's not very good for the environment. So some scientists wondered if ponies that lived on the moorland, if they could keep the number of evil heather down. So what they did was they got salt blocks, put them on the moors, because the ponies are attracted to salt blocks. And then they got this transect line from the salt block going out into the distance where there were no ponies. And they used their quadrats to measure from the salt block to not where the salt block was. And yeah, they did find a pattern where they had encouraged the ponies to be. They were eating the salt, but they're also like, oh, good, tasty evil heather, and eating the heather as well. So that was like a study that proved that you can use ponies instead of fire to destroy evil heather. Right, talking of real life examples, a little quiz for you before we end then. Is lichen. It's lovely stuff, isn't it? It looks like a plant. It's actually a plant and fungus working together. So how many different species of lichen are around, that we call that the lichen's diversity, okay, is a very good way to tell how polluted air is, right? The cleaner the air, the more different kinds of lichen you find. I knew this. I didn't know that scientists have actually got something called a lichen diversity value. So if you want to know how clean the air is in your area, you can scientifically measure the amount of lichen that are around, the lichen diversity, and that gives you like a number for how clean the air is. So to measure the lichen diversity in area, you put little quadrats on trees. You get really small quadrats, you just stick them on trees, measure the amount of different lichen that there are, and that gives you this number. But there are various rules you have to follow. So I thought I'd get you thinking about like what's a fair test and what's not. I've just got 4 multiple choice questions for you. So that we've just been looking at abundance so far. Abundance means how many of a thing there are. So like count how many dandelions, the abundance of dandelions. Now we're talking about diversity. So if your quadrat was just full of red lichen, you'd only be able to write down 1, because that's just one kind of lichen. People are counting how many different species of lichen appear in their little quadrat. An important thing to note is the reason that lichen is really good for this is because it grows all over the world. It grows in the Arctic and it grows on the equator. So scientists can get a number using lichen for how polluted air is, and they can compare it with other scientists. So bear this in mind as you're answering these questions. You want to come up with a result that you can compare with other scientists around the world. So, first of all, if you want to get a good lichen diversity number, what kind of tree do you put your teeny tiny little quadrat on? Do you choose trees with trunks over 1 centimetre wide, trees with trunks over 80 centimetres wide, or trees of any size? Question 2, lichens need light to grow. So what kind of conditions should the trees that you choose, what conditions should they be in? Are you only going to measure trees that just have light, or that just have shade, or that have light and shade? Number 3, which side of your tree that has been selected are you going to measure? The north and the south side, the east and the west side, or the north and the south and the east and the west side? And number 4, do you record all species of lichen that you find? Or are you going to leave any out? Are you going to say leave out species that are very difficult to identify? Are you going to leave out species that are hard to find? Are you just going to record all species? Or is it A and B if you want the best result? So have a think about that. It's not easy. I wouldn't have got all of them, but there is a logic behind them all. All right, should I go for the answers? You've been thinking that one through? 5 seconds. Try and give a reason as well, yeah? Okay, what kind of tree do you put your quadrat on? It is recommended that they choose trees over 80 centimetres wide. I'm guessing the answer to this is maybe partly because a very, very, very thin tree is going to be very young, so maybe lichen haven't had time to establish. And also a very thin tree, I guess there might not be room for very much lichen as well. So you've got to make sure that if there's not much lichen there, it's sort of very likely that it's because there's a lot of pollution and not just because you've used a tiny little tree, a very young tree, okay? Kind of the same with the second question. They only choose trees. I guess you would sort of choose the area of tree randomly, but you only choose trees to study that are in the light. Because again, if you choose trees that are covered in shade, that might be why there isn't much lichen and not because it's a polluted area. Which side of the tree do you measure? The answer is all sides of the tree. God, I'm telling you, biologists are absolutely, I think all scientists, a lot of all scientists' work is just incredibly tedious, isn't it? You've got to measure every side of the tree because you might be in an area where there's a really icy wind blowing in from the north, or where it's always very, very bright in the east. So again, you've got to make sure that you've got lots of results so that the reason why there's a lot of lichen or not much lichen is more like it speaks of air quality. And this last one was quite surprising. They actually recommend that you don't count lichen species that are hard to identify, and that you don't count ones that are hard to find. You would think, wouldn't you, for a fair test, you should just record all the lichen that you see. But that's mainly so that when it comes to comparing results with other scientists, it's more likely that you've got the same results. So if there's 2 species of lichen that look really similar and you've got to be an absolute pro-lichen expert to tell them apart, it's easier for everyone if you just go, oh, don't count those ones. And then it's likely that everyone gets the same result, okay? Whoa, right, you lot. That is the end of the ecosystem lesson for this week, which means it's the whole end of the ecosystems topic. I'm kind of quite sad. I've really enjoyed this one. It feels like we've covered loads. There is obviously a lot more to cover, and we will look at biology again, but I'm now going to take 2 weeks off for Easter. And then when we get back, we're doing waves. We're studying waves. There's so much to study. So we're going to look at like ocean waves and rainbows and sound waves and earthquakes. There's so many different activities to do with waves. I'm very excited. So 2 weeks off for Easter, and then the 18th of April, we're going to start our waves topic. I thought I'd do a very quick little quiz for you because you guys love a quiz, you know. And this is the end of the topic. So if this is the first lesson that you've jumped into, this might be a bit tedious for you, but for people who've been to all of the lessons, let's see how much you remember, okay? Question number 1. I have a bird's a bit close. It looks like it's about to carry the bee away. I've got 3 organisms here, one on top of the other. I've got a flower. On top of that, I have a bee. And on top of that, I have a bird. Can you tell me, please, if I want to draw arrows to make this a food chain, which direction should the arrows go? Should the arrows go up? Or should the arrows go down? Which direction should the arrows go on a food chain? Are they going to go from the flower to the bee or from the bee to the flower? 5, 4, 3, 2, 1. You remember when you draw an arrow on a food chain, you've got to say, like, is eaten by. So the arrows go up. Looks a bit rude, into the bird's bum. Give yourself 1 mark, well done, if you said that the arrows should go up. Question number 2. This plant down here is what we would call the producer, because it produces food using energy from the sun for the whole rest of the food chain. But what is the name for the bee? If the flower is the producer, what is the name for the bee? I'll give you 10 seconds. It's a 2-mark question. I'm just refreshing my Facebook page while you answer that, because there is a hastily thrown up post saying, if you're watching live on YouTube, you want to say hello, please go on this post and say hello. Oh, brilliant. Oh, hello, Kim and Mary. No, it's the first time Kim and Mary have watched live. Oh, that's awesome. Hello. Oh, how nice to hear from you. So nice to be able to say hello in person. All right, the answer is, give yourself 1 mark if you wrote consumer. Well done. But give yourself 2 marks if you wrote primary consumer. Fabulous. Because it's the first consumer, the one that eats the producer. So the bird would be the secondary consumer. Very well done if you got that. Primary consumer. 1 tick. Primary consumer. 3rd question. Please could you sketch me, just sketch, don't be getting your ruler out. Can you sketch a pyramid of biomass for this food chain? Can you sketch a pyramid of biomass for this food chain? This is also a 2-mark question. Please sketch a pyramid of biomass. Hey, it's Suki and Naza and Eunice and Salah. Hello. Arrows up. Well done, very good. Oh, hello, Serenity and Brandon. Nice to see you. Sketch for your life. Oh, it's Izzy and Elodie again. Hello, you having a science day? Hello, Sky and Evie. Gutted last lesson, but yay Easter. Yeah, I know, I feel the same way actually. Yeah, I'm quite sad. Hello, Dawn. Hey, Tiger and Bird. Hello. Right, have you sketched it? So if you have sketched 3 rectangles with the biggest rectangle on the top, biggest rectangle on the bottom and the smallest one on the top, well done. That is 1 mark. And if you've labelled it, do you remember this? If you've labelled it so the flower's on the bottom and the bird's on the top, then give yourself another mark, so the bee's in the middle. Okay, so if you've done a pyramid with big on the bottom, small at the top, that's 1 mark. And if you've labelled it so you knew that the flower was on the bottom and the bird was on the top, then that's another mark. Well done. Okay, 2 more questions. Let's just focus on the bees. If you are studying just 1 species of bee, okay, all the same species, all the sisters and brothers together, what is the correct name for a group of animals, all of 1 species? Is it, oops, I'm writing backwards, this is YouTube, but I have to write backwards. Is it community? Is this a community of bees? Is it population? Is this, if you're counting how many bees there are, is that the bee population? Or is it genus? What is the correct name for a group of animals, all of 1 species? Hey, Charlotte's here, hello. Hello, Corrie. Oh no, I want to read all the comments, please. This is tricky, this one, this is really tricky. It's tricky because a lot of scientists just totally ignore this rule. But if you were doing like a GCSE, then you would have to use 1 answer. All right, Joe. Oh, well done. Yes, first consumer. Yeah, I mean, that's very good because obviously you knew. I don't know if it was like a GCSE, I don't know if you'd get that or not, but I'm going to give you it. Hello, Casper and Sarah, having a total theatre science day. Yeah, me too, obviously. There's a yellow butterfly in my garden. That's the first butterfly I've seen this year. Oh, how lovely. The correct answer is population, actually. they're all the same species, the correct answer, this is a population of bees. But we're looking at how scientists just don't care. We remember we looked at that study of bottlenose dolphins, and they were like, a community of bottlenose dolphins. No, strictly speaking, more than one species. So like if one of them was a bumblebee, then that would be a community, because it's animals that are more than one species. But strictly speaking, it's population. And finally, so this is out of 7, isn't it? So that was 1 mark as well. What is the correct name for the kind of picture frame type thing that scientists use to count animals? Is it A quadrant, B, a quadrangle, or C, a quadrat? What is the correct name for the picture frame type thing that people put on the ground? Hello, Alexis, Evie and Sky, Izzy and Elodie, Charlotte. Oh, look at this, I've even been sent sketches in the comments. Oh my goodness, we live in the future. Hello, Jane. Oh, hiya, Sailing. Hello. Yeah, nice to hear from you. Brilliant. Right. The answer is, hopefully you got this one. I was a bit worried because I'd made a mistake on the sheet. It is quadrat. Brilliant word. Yeah, quadrat is the name. So well done. Give yourself a mark out of 7. If you got 7, well done. If you got 0, doesn't matter, does it? You know, I don't even have to know. And even if I do know, I just say very well done for being here. You're not going to do an exam on this anytime soon. The whole point of this is that, you know, if you didn't remember it, you do now. So well done. You're all winners as far as I'm concerned. Oh, Emma and Joe. Oh, nice. I like that Emma and Joe are disagreeing. That's really good. Hello, laddie. It's, you know, it's like it's discussion. It's what science teachers like the most. Okay, you lot. Right, I'm going to go. I've got a lot of you came actually. But if you didn't come, then I'm doing the Lego Storytime show about eggs at 2 o'clock, which is in 1 hour and 9 minutes. So I'm going to go and have some lunch. Oh, hello, Brandon and Serenity. Have I said hello to you? I don't think I have. If you want to support me, you can. People are supporting me, and that is how this is my job. If you go to my About section on YouTube, it takes you to this website called Coffee, where you can support me with £5 or £6 a month. And I will send you nice things to say thank you, because you are literally paying my wages, and this is the best job that I could possibly imagine having. So if you search Coffee and Theatre of Science, wow. Just this advert just gets slicker and slicker, doesn't it? If you search Coffee and Theatre of Science, you can send me £5 a month, and I'll send you rainbow glasses that make you see rainbows. Quite good for the waves topic coming up. Yeah. I'll send you an explanation of how they work. I'll send you Theatre of Science magazine. So the latest magazine is on sleep. It is just arriving right now to my supporters. You've got a little piece of fabric in it and a little bag of lavender so that you can make yourself a little sleep squish. If you haven't got it, then let me know by, I don't know, the end of next week, and I'll send you another one. Okay, right. I am going to go. Thank you so much for coming. Thank you so much if you're watching this on catch-up. I mean, I don't know why you're still here, but thank you very much. I'll see you all soon. Have a lovely evening.